Hello everyone, welcome back to the channel. Welcome back to our DSA series. In this video, we are going to learn a new data structure, that is stack. Now, what is a stack? So, stack is a data structure that follows LIFO order. Now, what is the LIFO order? LIFO means last in, first out. That means the element that is being added in the last, right? That will be the first to retrieve. I'm going to show you this in a graphical representation as well. Okay. So if you talk about use cases, right, I have mentioned here undo feature, compiler design, expression evaluation, and browser navigation. So if I talk about this undo feature, right, so when let's say you're working on a Word document, right? So when you're working on a Word document, right, you're writing something, you keep on writing new lines, then you suddenly realize that you have done some grammatical mistakes in previous word. So what do? You do Control Z, right? Control Z, you go one step back, right? The word or the letter that you have written just now, right? Then you do Control Z again, then the cursor moves to the word or the line that you have written just before that, right? So immediately just you have written, right, on top of the sentence, at the end of the sentence, that thing only getting removed when you're doing Control Z. That's what is called LIFO, last in first out order. Let me give you a few more examples to understand it better. So in compiler design, if I tell you, so whenever compiler design, right, there is syntax to be taken care whenever a new compiler is being designed. To make sure that syntax is properly being followed, things like braces, or whenever you're opening brackets or closing it or not, things like that. So not just that, even a simple expression also you can evaluate using stack, right? So there is a popular question in stacks which is balanced expression. We'll be doing that question to dig deep into this expression evaluation thing. Now, browser navigation. So browser navigation, as we know, so whenever you are clicking on a link, right, it's taking you to another website. Then you're clicking on another link, it's taking you to another website. Then you have a back button. Whenever you're clicking on it, it is redirecting you to the most recent website that was opened, right? Again, you click on back button, it takes you to the most recent website before that. So that's also a good example of LIFO and stack data structure both. So in stack, generally we perform these operations, mainly insert operation that we call push, removal operation that we call pop. Peek gives you whatever the element is on top of the stack. Size to calculate how many elements are there in the stack and is empty, to check if your stack is empty right now, right? So what do I mean by stacks are not meant for lookup? Basically in stack, you can only access the element which is at top of the stack. So suppose you want to look up for some particular element or object which is at the bottom of the stack. So it will take a lot of time, right? You literally have to remove all the elements from the top to reach to bottom, right? That's why stacks are never meant to use for lookups. And all these operations which I have told here, right, push, pop, peek, size is empty, every single operation happens in constant time, that is O of one operation. So now let me show these things in a graphical representation, and then I'll show you how do we use this in language as well. Okay, so we are talking about stack, right? Let's say this is your stack. Okay, let's say you have three numbers, right? 4, 5 and 6. These three you want to insert in this particular stack. Now how do you insert it? Let's say you have to insert 4 first. So okay, you have added 4 here. Now 4 is at top of the stack. Now you want to add 5. Now 5 you can add only at the top of the stack only, which is this. Now 5 is at the top of the stack. Now you want to add 6. Now 6 again will be added at the top of the stack only. So whatever new elements you want to add in stack, right, those can be added only at the top of the stack only. Now I have told you about that peek element, right? So peek will give you whatever is there on top of the stack. Peek will give you this 6, right? This is currently at the peak. Now I said it follows the FIFO order, that is first in first out, right? So if you want to remove the elements from this stack, how you will remove? So whatever the element which was inserted last, right, that will be the first to be removed. So if you want to remove, 6 will be removed first, right? Now your stack after removal, it will look like this. Now 6 is being removed from there. Now 5 is at the top of the stack. Now once you remove 5 will be removed from stack. Then you have only one element left in your stack, that is 4. And now after removal, all the elements will be out and your stack will be empty, right? Now if you check for peak, you will get nothing, empty. Now I hope you understood what I'm trying to explain by this stack structure, right? You add element on top of the stack, you remove element from top of the stack, okay? And whatever the element is on top is called peak, right? To insert element into stack, we have operation that is push. To remove, we have pop. To check the top element, we have peek. And you have other also two helper methods, which are, let's say, to check if your stack is empty or not, we will implement this method, is empty. And also we can have size method. These are very common methods. So beside this push, pop, peek, we will implement all these methods. So have you understood what stack is? Let me show you that in Java code also, so that we can move on to next questions. So let's check how do we use stack from Java code itself, right? So for that, if we create a main method, in that let's create a stack, not Stack Overflow. Stack Overflow is also very interesting. You know the website called Stack Overflow, right? So when the stack is completely full, right, you cannot add more elements to it. That's when you get Stack Overflow exception. That's how the website came into picture and all those things. Let's say we want to create a stack of integer. I have imported that class. Stack is equal to new stack. Now what I'm doing, stack dot push 10, stack dot push 20, stack dot push 30, right? Now if you check what is the element which is at peak of the stack, right? So what is the element that you added last, right? You have element, in the last, the element that you have added is 30. So 30 should be at the top of the stack. Now if we run this, we should get 30. So as you see, you're getting 30, right? Now let's say you want to remove, right? Removal also you can do only from the top of the stack. Now at the top of the stack, 30 is there. So if you do stack dot pop, right, you will get 30 only. Now after removing 30, what is the element that is at top of the stack? That is 20. So now if you want to check again what is the peak element at the stack, right? Now you will get 20 because 30 you have already removed. Now you're getting 20. So these Java stacks are very simple and easy to use. All these implementation I'll be showing you. It's very simple and easy to implement, right? We'll be implementing stack using an array with all these operations like push, pop, peek, size is empty, all these methods. So that's all about this particular video. It was an introductory video for stack. I hope you were able to understand it. That's all about this video. See you in the next one. May the source be with you.